Hey folks, welcome to the video on distributed monitoring for machine learning scenarios. We're going to go through the sample, the use case. We had a real customer. For now, we're going to call them Contoso so that we can help protect the identity and things like that. Contoso was building a distributed machine learning solution that had inference or processing at a couple different parts. We've simulated that, as you can see here in this application map. In the bottom, we have an Azure function, which then calls a web application, which then hits a SQL database. So this is similar to what they had, and there's things happening at each spot. The problem is figuring out that at the end of it, there's a 30 or 40% error rate. How do you tell which part is producing how much error, and how you get to the key information that's generated at each of those stages so that you can add it into your training data set? This is exactly the problem that our customer had. The wonderful thing is that after implementing this type of monitoring solution, they were able to drop their error rates from 30% to less than 10% by being able to identify which part of the solution was causing the performance problems and then prioritize which data they should focus on inside of that. So that's what this solution is going to walk through, and how we reduce those error rates and optimize those multi-part machine learning models. You could use the same paradigm for a couple of other things. So if you need to understand calls going through the system and there's a part that has 200 milliseconds and you have a 100 millisecond turnaround time, we can see here that the communication between the HTTP and the web app instance has a 220 millisecond response latency time. So we need to figure out what specifically is happening there. It likely has something to do with that 51% error rate for failures. To solve this, we use a paradigm called distributed tracing, and we follow the W3C standard that allows us to integrate with different Azure components and see the end-to-end traceability, not only within our system, but because the various Azure components adhere to that standard, we can see the interactions as well, and you can see that here on this application map. Essentially, what distributed tracing does is allows us to see a single thread go through the entire distributed system and understand what's happening at each one of those points and record information for that particular operation, and it's called an operation ID. In this case, we're logging specific information. We've kind of made up some metrics. So we have a data drop location. The HTTP trigger is going to store a random text file in Blob storage. That would be analogous to our customer who was storing incoming information that was pertinent from an audit perspective that was then processed, right? Then it takes that processed information that originated from that file and then sends that over to the web application. The web application then logs some kind of metric. In this case, we called it a flux capacitance. This could be your confidence score for a particular prediction or some other type of metric that's important to you. What we are going to look for is how can we find confidence scores or flux capacitance that is over or under a specific threshold, and then be able to find the individual requests where that is the case, and then find the original data so that we could then use that for putting back in our machine learning system. And now Sophia is going to take us through how do we actually execute a query and find some of these problematic requests. Sophia, can you take it away?
Yeah, of course. Okay, as David mentioned, we can use these custom metrics to see what is the specific request that have a specific number or indicator. So we go to logs, and on logs we have this particular screen where we can query some specific requests. So we use custom events because this is a custom metric where custom dimensions flex capacitance it's greater than 8.0. So we just run this query and we will be able to receive all the requests that has this specific metric greater than 0. So we want to here and we're able to see that the flex capacitance is 8.89.
That's great, Sophia. How do we actually use this and find the blob and the other requests that were associated with this? So this, this guy here caused us a problem. How do we go find the data that caused this metric further downstream in the system?
Okay, now searching with custom events, where operation ID is equal to the operation ID that we have here, we can see the location of our blob. So we have two custom events, the one that show the flux capacitance and where we have the blob data. If we go to custom dimensions, we will be able to find the information of the name of our blob.
So that's great, Sophia. Can we actually open up the Blob Storage Explorer and find this particular file?
Yeah, definitely. Yes, we can find this blob in the Storage Explorer. So if we just copy the name of the blob and we go to our resource group where we have a storage, we can go to blob containers. Inside our blob container, we have a specific blob container that is called out container 01, and we can search for our specific name of the blob. If we go here and we go to edit, we will have the information.
Perfect.
Yeah.
So now we've got a blob name and some data in here, and obviously this is what's causing the problem. Somebody put some bad data in there. So there's a couple of different types of high-level tables that you can search across, and operation ID will be available for most of them. So if you want to get a holistic view of how a particular operation has interacted through your system, you may need to query across a few. So these custom events are specific events that our application is logging. There's also the ability to take a look at things like requests. So if we go ahead and search for requests where the operation ID equals this particular ID, we'll see some of the out-of-box application insights logging. You can also use the API to log to the requests as well and try to consolidate either via requests or custom events. So here we can see there's several requests that happened as part of this total operation. This get on the index, we're kind of confused about that at first, but it actually turns out that the page as a response to the random metric that generates the flux capacitance actually gives us back and does a get on that particular page. Also, we have dependencies. So as part of using the W3C standard, when you use this operation ID and adhere to it, you can see which other components you're taking dependencies on. So once this query runs, same operation ID, we'll be able to see that there's a couple of different systems, including SQL Server, that we're interacting with, where there's a dependency formed, and that helps with the directional arrows in the application map. And now Sophia's going to show us how she implemented the W3C standard in a Node.js HTTP trigger function. Sophia, take it away.
Yeah, thanks, David. Okay, I will walk through the code a little bit to show you how we implement W3C standard in our function. We have inside CRC functions folder, we have our HTTP trigger function. And if we go to index, we will be able to see at the beginning that we are calling our application insight, and it's where we are initiating this W3 standard. And if we scroll a little bit to the bottom, we will be able to see that we have application insight wrap, where we are using this to basically wrap and get a correlation context ID, that is the one that we use to trace all the traceability of our requests through the system.
Sophia, that's great, but I don't write code in Node.js. I'm a .NET Core developer. How do I do this in .NET Core?
Oh, thanks that you mentioned that, David. Okay, let's go to the web app and I will show you that you don't have to write nothing special in .NET Core, because if you are using Microsoft Application Insights.sp.NET Core greater than the 2.8.0, this came automatically. It's part of the package. So just let me show you.
You mean I don't have to write any code to get this implemented in .NET Core?
Exactly. The W3C distribute tracing standard, it's already supported for ASP.NET Core apps that are using this package of Microsoft Application Insights.sp.NET Core greater than 2.8.0.
Wow, that's great. Thanks, Sophia. So that's great. That's an overview of the use case and the demo. We have another video which you should go check out, which walks through how to actually deploy the solution and a walkthrough of all the deployment automation that went into making it a single script that deploys absolutely everything to Azure. So thank you very much. And Sophia, thank you for being wonderful and helping us walk through that solution.
Pleasure. Thank you, guys.